Hey Algebra 1, here are your notes for 12.3 talking about multiplying rational expressions. So before the video has even begun, I would like you to pause it and try these first three on your own. Let's see how good your intuition is. Let's start by using some of those techniques that we've already learned as well. So try a few things. Once you've attempted them, come on back. Alright, hopefully you paused the video long enough to give these a shot. I hope the first one wasn't too tricky, but in case it was, we're going to go over it together. So I personally find that there are two methods to solving these. There's the easy way and there's the hard way, but I do want to show you both in case one or the other doesn't make sense to you. So the first way is just simple multiplication. When we multiply fractions or rational expressions, we multiply across the top. 2 times 15 is 30. Multiply across the bottom, we get 12. And then from here, we simplify. I notice both of these are divisible by 2 and by 3. I'm going to start by taking the largest commonality I see. If they're both divisible by 2 and 3, that means they're also both divisible by 6. So when I divide the top by 6, I get 5. When I divide the bottom by 6, I get 2. And so my simplified answer is 5 over 2. Now that's the hard way in my opinion. It definitely works. It's very reliable, but there's an easier way. If we go back up to the original problem, one thing that I really like is because multiplication happens in any order, I can move around numbers as long as I stay above or below the line. So for example, I could switch this entire problem to be 15 over 3 times 2 over 4. Now why would I want to do that? Well, because we're multiplying across the top and the bottom, I'd still get 30 over 12. I haven't changed anything. But by moving things, I can now see that 15 divided by 3 is 5, and 2 divided by 4 is 1/2. I can simplify those a lot faster and say that it's 5/2. Now notice, you get the same answer either way, but my intuition tells me that this is going to come in handy. Because what did I essentially do here? Well, I essentially cross-reduced. I noticed that 15 over 3 reduced to 5 over 1, and 2 over 4 reduced to 1 over 2. Once I was there, I still just multiplied across and got 1 times 5 and 1 times 2, and even that method got me 5 over 2. So whatever method you use, they all work. But what I'm going to suggest is that you use the cross multiplication method that we get from doing this. Let's see that with variables. Let's cross reduce this one. A divided by A, because there's only multiplication going on here, A divided by A reduces to 1 over 1. C can't be reduced by B, but 1 times C is C, and B times 1 is B. That wasn't bad. Well, the thing is, it gets trickier, but the methods still work. We have x minus 1 over x minus 1. Those can reduce as long as we reduce the entire phrase. They have to be in these parentheses. We can't reduce the x and the x here. That doesn't work because these are technically in parentheses and we cannot break things up without being the exact same. So these cross-reduce. They're the exact same. And now I've got x squared over x. Well, from our exponent unit, we know that x squared divided by x is just x on top. So this reduces to x over 1. My final answer is x times 1 over 1 times 1, or just x. I love multiplying rational expressions because all it is a ton of reducing problems just like this. However, even though it's a lot of fun, we have to be very careful with how we reduce things. So one of the things I want to show you, x over x reduces to 1. X minus 1 over x does not reduce to -1, folks. put a little cloud of darkness around that. That's not good. We don't like that. I wish I had put that in red so we could say that's bad. But this is the big idea that you need to remember going forward in this video. We cannot reduce things that are not the exact same because the parentheses police, essentially, are stopping us. All right, let's keep going. Obviously, like I said, they get more complicated. So what are our thoughts on dealing with this? Well, I've already showed you the two methods, but I'm going to show them to you again. The first method is where we change things around. We move the two tops. So this becomes 16c to the third over 8c squared times 5ab cubed over 15a squared b. This is easier to cross reduce because now we're just reducing fractions. Nothing wrong with this method. 16 over 8 is 2, c3 over c2 is c. So my left side becomes 2c. I then need to multiply that by this reduced. 5 over 15 is the same thing as 1 over 3. A over a squared is a to the negative 1 on top, which we then move to the bottom. And b to the 3 over b becomes b squared on top. From there, we just simplify. How do we multiply a whole number by a fraction? Well, we put the whole number over 1 and multiply across the tops just like we did before. So 2c times 1b is 2cb squared. Multiply across the bottom, 1 times 3a is 3a. Just like that. So method 1, move the numerator. I'm going to say move the num. Method 2 is that cross reduce. This one is doing the exact same thing. All it does is it leaves things where they are and reduces them that way. So this way, cross reduce, I don't know why I like to start with this diagonal and then go this way. Just a me thing. 16 divided by 8 is the same thing as 2 over 1. C cubed divided by c squared. The c's go away here, and I'm left with a c up here. So now I'm essentially left with the fraction 5ab cubed over 1 and 2c over 15a squared b. Now I'm going to go the other way. 5 over 15 reduces to 1 over 3. A over a squared. I lose an a up here. I'm left with 1 down here. B cubed over b. I'm left with 2 b's up here. Now we multiply across just like we did before. B squared times 2c is the same thing as 2b squared c. Over 1 times 3a is 3a. I check myself in both of these for 2 ways. 1, I can't reduce these fractions any further. 2, I got the exact same answer, minus the b squared and the c are switched, but it doesn't really matter. And since I got the same answers, I know that I'm right. So, whether or not you prefer to move the numerators, or whether you prefer to cross reduce, it doesn't matter. For the sake of writing things, I personally prefer the cross-reducing method, and that's what I'm going to continue to show in this video. Alright, what are your thoughts on tackling these? Please remember the cloud of death that I showed you at the beginning of this video when you're thinking about those. Alright, hopefully you've got an idea here. Remember when I said we can cancel or reduce things that are the exact same, but we cannot reduce when there's addition and subtraction involved. Notice, this is all multiplication. We can multiply these until we are blue in the face. It does not matter, because no matter what order you multiply the top and the bottom in, you're still going to have the top over the bottom. Doesn't change anything. So, my cross-reducing method works here. So, z plus 4 divided by z plus 4 cancels out. It's just 1 over 1. They're the exact same separated by multiplication. so I can cross reduce. Same thing with this z plus 2. I've got a z plus 2 on top. I've got a z plus 2 on bottom. That's just something divided by itself. It's just 1 divided by 1, folks. Now here's the tricky bit. I have a z minus 1 on top and a z minus 1 on top. But I can't reduce those. Why can't I cross reduce those? It has nothing to do with what side of the multiplication sign they're on, and it has everything to do with what side of the line they're on. They don't divide by each other like these do. Z plus 4 divided by z plus 4, it's going to be 1 every time. But z minus 1 times z minus 1 is not 1. It doesn't reduce. So let's simplify this out. We've got 1 times z minus 1 times z minus 1 on top. Essentially this. And on the bottom, we've got 1 times z. Don't forget that little z down there. He's still down there. And remember what I said earlier. If you have something x minus 1 divided by x, it does not equal that number. Things are reducing. Things are canceling out. But the x's are not, and neither are these z's, folks. This doesn't cancel. This is it. You can't cancel anymore because they aren't the exact same. Now you can leave it like this, or you can FOIL this out so that you get z squared minus 2z plus 1 over z. But even if you FOIL it out, there's no z's canceling. This is it. Because guess what? You got addition signs and subtraction signs in there. We don't break things up over addition and subtraction. There's nothing that's the exact same. Even if this was a plus z in here, it doesn't cancel. So in addition to this cloud of death, I want one other thing to be written down. We do not cancel when separated by addition or subtraction. We do not cancel over addition or subtraction. Bad. Don't do. We don't like that. All right, let's look at the next one. Well, crap. I can simplify x squared over x. That just becomes x and 1. Pretty slick like that, right? But now I'm done. Except you're not. It's really hard to see if anything cancels when we've got this big, nasty trinomial looking at us. It'd be really nice if I could see if maybe there was an x minus 5 hidden inside of this trinomial. And unfortunately, only way to find out is to break this down, is to pull it apart. No x, no number in front, no x puzzle needed. So I'm going to break that down. I'm going to say x and x. What multiplies to 15 and adds to negative 2? A negative 5 and a positive 3 will do it. Remember when I said that was one of the most important skills to have and be good at in algebra? It's going to keep coming back, folks. All right, so now that I've broken this up, I'm going to rewrite this actually so that I don't have so many fractions to look at. I'm actually just going to cross this whole thing out. I've got x minus 5 times x over 1 times x minus 5 plus 3. Hey, conveniently enough, I see something that is the exact same on the top and bottom. And because there's no addition or subtraction separating my parentheses, there's only multiplication signs, those can cross-reduce to 1. All right, let's regroup because there's a lot of pen marks going on here. I've got 1 times x on top. I've got 1 times x plus 3 on bottom. Hey, happy day. This is where we cross out the x's and we just get positive 3. No, bad. Don't do that. Please do not simplify this any further. If they're the exact same, they cancel. If they are not the exact same, they do not cancel. Bad. Notice, these do not cancel. This is as simple as it gets. We cannot cancel or reduce. I know some people do not like the word cancel in the math world. I don't care. We do not cancel or reduce over plus or minus. I've got an addition sign here. Those parentheses are holding me together, so I cannot reduce. All right, let's keep going here. Ooh. All right, that is a big, nasty problem. I know that you can do it though. I want you to pause the video now. Try to break this up into as much as you possibly can. Cross reduce, cancel, use whatever method you have to, and then come on back, we'll give it a try. All right, I hope that you had a great time with that problem. I know some of you don't like math, but I love these type of problems. So let's get to it. The first thing that I always do with these problems, I break everything down into as many small parts as I possibly can. So I'm gonna go over here, I'm gonna break the left side down. First thing I notice right off the bat is one of my favorite things in the world. This is a difference of squares. I've got a square and a difference, so I know that I can automatically put it into the form a minus 5, a plus 5. I'm going to keep bringing back those things we've already learned this year. I hope that you remember them. I can't simplify a plus 1 any further than it already is, so I'm just going to leave it alone. Now let's simplify that right side. We've got 3a plus 3 over a plus 5. Well, I right away know I can't simplify the bottom. There's no GCF, there's no squares or anything. But the top, I notice that both terms have something in common. They have a 3. And when I pull out that 3, I'm left with a plus 1. Once I have both sides simplified, I like to bring them back together. I like to simplify the entire problem. So I have a minus 5 times a plus 5 over a plus 1 times 3a plus 1 over a plus 5. Now that I've got this simplified and it's a little easier to look at, we can start our cross reducing. Right away, I notice an a plus 1 and an a plus 1. They're the exact same and they're in parentheses. Everything is separated by multiplication. There's no hidden pluses or minuses in here. So I can cross reduce the a plus 1 and the a plus 1. I'm going to stop writing the ones up in the corner because when you cross reduce like this, you just cancel them out. Unless it's something like 15 over 3 where it becomes 5 over 1. If they're the exact same, I don't have to write that one. I also notice that I've got an a plus 5 on top and an a plus 5 on bottom. I can also cross reduce those. Now, is there anything else I can cancel? Since there's nothing else on the bottom, the answer is no. So, what am I left with? A minus 5 times 3 over nothing times nothing. So I'm going to write it this way. 3 outside of a minus 5 over 1. Now I could leave it like this, but that's not how mathematicians leave their answers. We want to make this as simple as possible. So what I'm going to do is I'm going to get rid of the denominator. I don't need it to tell me I'm dividing by 1. And I am going to simplify the top to be 3a minus 15. Just because now it's one cohesive idea, there's no parentheses to confuse me, and it's clear that we can't simplify it any further. All right, find the error. Amiri and Hoshi multiplied the quantity x minus 3 divided by the quantity x plus 3 and 4x divided by x squared minus 4x plus 3. Who is correct? Well, I personally could go right into these, but as a mathematician who knows that they're really good at math, just like you all are, I'm going to go over and do this problem on my own, and then I'm going to compare it to theirs. So, if you want to, you can be a little bit whimsical and say, Amiri's got hers, Hoshi's got his. I'm assuming they're guy and girl. I guess they could be anything, but I'm going to put mine right here. So I've got x minus 3 over x plus 3. Notice they're not the exact same, so I cannot cancel them, times 4x over x squared minus 4x plus 3. All right, remember, first things first, simplify, simplify, simplify. Can't really simplify anything over here, can't really simplify 4x, but this big ugly trinomial, I can simplify that into 2 parentheses, because once things are in parentheses, I might be able to cancel them. No number out front, no x puzzle needed, xx. Okay, what multiplies to positive 3 but adds to negative 4? That would be a -1 and a -3. And then I'm going to move the 4x over here and just cross this out, so I'm not looking at so many things. So now I've got x minus 3 times 4x and x plus 3 times x minus 1 times x minus 3. Hey, cool stuff going on here. I've got an x minus 3 on the top and the exact same thing x minus 3 on the bottom. Since I'm only working with multiplication, there's no addition, subtraction outside of any parentheses. I'm good to go. So I'm going to go ahead and bam, cross those off. There's nothing else that I can cross reduce, so I'm going to bring it back. The only thing left on top is 4x. The only thing left on bottom is this x plus 3 and this x minus 1. I could put them separately down here, or I could FOIL it out to give a final answer. In this case, I think I'm just going to leave it like this. On quizzes and tests, I would prefer you to also leave it like this. If it's really simple, it's only one answer, simplify it. If it's a fraction, leave it like that. All right, so now I've got my answer to compare it to. Now let's jump back over to Amiri and Hoshi and see what they got. Oof. Amiri got the same answer as me. Hoshi did not. So I'm going to go through and I'm going to start looking to see if Hoshi made a mistake or if I made a mistake. All right, Hoshi started off by writing them, but the first thing they did was they crossed out those the 4 x's that were there. However, why can't they do that? Well, because if you remember our second little cloud of death down here, technically it wasn't a cloud. I didn't cloud it in. Hold on, I'll do that for you so you don't feel slighted. This is our second cloud of death. We do not cancel over addition or subtraction. Problem is, we can't cancel those because we have a subtraction right here and an addition that are not taken care of by parentheses. Notice when they did that, they canceled out these as well. They also said there's an x minus 3, and they can cancel that. They can cancel the 3's out. And they've got a negative over a positive going on right here. That doesn't work. We don't cancel things because the parentheses keep them all together. He's just canceling things that do not get to be canceled. So, Hoshi, man, you broke rule number 2. It doesn't work. We cannot cancel like that. So, who is correct? Amiri. And then why? Hoshi, first, he canceled / reduced over addition and subtraction. That's bad. That doesn't work. Second, the way that I would write this is x minus 1 over x does not equal -1. I know that's not really an explanation, but it kind of shows the error that he made when he canceled x divided by x when there was a minus and a addition in the middle. So he made 2 pretty big errors. All right, moving on. Simplify these last 2 problems, and then we're going to work on that practice set. So pause the video, give these a shot, and then come on back. We'll do them together. All right, I know I've had a lot of pausing of the video. Hopefully you're back. Let's go to town and start cross-reducing. 42 divided by 6 is going to be 7 over 1. N squared over n cubed. There's one more n down here, so that's where it's going to stay. 10 divided by 35 is 2 over, divide both by 5, yep. So 35 divided by 7 is 7. Oops. And R3 divided by R3 is just, boom, 1. Oof, now I am left with 7 over 7 and 2 over 1n. Well, 7 over 7 is equal to 1, so I just have 2 over n times 1, or 2 over n. Oh, that was a quick problem. All right, what about the next one? Oof, trinomial, right there, right away. If you see a trinomial, you should go, before I can even start this problem, I gotta break that down. So, no number in front of the b, no X puzzle needed. BB, what multiplies to 32? adds to negative 4. Would that be... No, that wouldn't be 8 and 2. 8 and 4? What is 8 times 4? Ooh, drawing a mind blank. All right, 8 and 4 will do it. 8, 4. Which one of them has to be negative to get a negative 4? Must be the 8. So now I have b plus 4 times b minus 8 over b 3. Cross that out so I don't confuse myself. I've got a b plus 4 on the bottom and a b plus 4 on the top. Everything is separated by a multiplication sign, so I am not breaking any mathematical laws. I can cross-reduce and simplify my b over b3 to be 1 over b2. And now let's bring it all back together. All that's left on the top is b minus 8. All that's left on the bottom is b squared. I cannot break anything else down because this has got an addition-subtraction sign. So that is my final answer. And in case you were bothered, because I didn't circle that, there you go. All right, there it is. Go try those practice sets on your own and definitely let me know if you have any questions.